So the reason why covalently compounded materials have such a range of melting and boiling points is because their melting and boiling point all depends on the intermolecular forces that exist between the molecules. So the stronger the intermolecular force, the more energy that you're going to have to put into it to make it melt, become a liquid, become a gas, because they're really stable in these different attractive bonds between molecules. Um, so that's why polar solvents, things, molecules that are polar, tend to have a lot higher melting points because they can do their dipole-dipole, they can do their hydrogen bonding. So that's why water has such a high melting point and why it takes forever for water to boil. Like, I always just think about it and like stare at the water when it's boiling, like thinking about all the IMFs that have to break so that it will boil. But yeah, it's super strong attractions happening there. But then non-polar solvents generally have a much less boiling point, melting point, because it's just London dispersion happening between them. Yeah, so then I have the chart kind of goes over, the chart shows all of these different types of molecules that range from polar to non-polar and how that affects their boiling and boiling points. And I have a video of water boiling, and I have a video of hot knife going through covalently bonded materials, which is pretty cool because it just shows the melting points and the generally low melting points, because these melting points are a lot lower than melting actual bonds that exist between atoms, because it is just a force that exists between the molecules, if that makes sense.